All right, welcome to day 10 of Math C. We're going to go ahead and talk about the confidence interval. So basically, a confidence interval, there you go. A confidence interval is an interval of plausible values for the characteristic. So basically, it's just a range where we believe it will be true of whatever the statement for most of the time. So therefore, a 95% confidence interval is just a range that we believe will include the true population parameter 95% of the time. So for example, if we're talking about our school, I could say 95% of the time we'll only have a fifth of our high school population show up to any dance. No, again, just kind of pulled that one out of nowhere, but that would be an example of 90% confidence interval. So before we go ahead and get started on taking a look at that formula, I just want to begin by saying this is going to be heavily done with calculators, and I'm not going to give you a whole lot of calculator time. So be aware that you may need to pause the video because it's going to be so intensive in calculators. So again, make sure you have the calculator. You're going to need it. You're going to want the scientific ones, the graphic ones, because we're doing some standard deviation again. Okay, so in order to find the 95% confidence interval, you're going to take the mean, wrong one, my apologies. You're going to take the mean value, or average, plus or minus 2, times the standard deviation divided by the sample size. So, we need that in our next example. So, in the article, alcohol and tobacco use in G-rated children's animated films, so like Disney movies, there's an investigation that showed that between the years 1936 and 1997, by 5 of the major film studies. So this researchers basically watched G-rated animated films released between 1936 and 97 from Disney to show how long of a time span in seconds you either saw alcohol or tobacco. So here are some times from Disney, and we're going to go ahead and construct a 95% confidence interval. So like I said in the slide before, we're going to need to go ahead and calculate the mean. We're going to need to calculate the standard deviation. So remember, when we do our mean, that's where we add them all up and divide by however many numbers there are. So here would be a good time to pause. When I add those all up, I get 2034. I'm going to take that divided by the numbers up there, and I have 17 numbers. So that gives me a total of 119.65. Then I'm going to plug all of those into my standard deviation. Now, if you can't remember how to do your standard deviation, go back to day 3, watch that video. It helps you put that all in. Once you do, so again, go ahead, pause. I get 144.34. So then I'm going to say I have my mean, which is 119.65, minus 2 times my standard deviation of 144.34, divided by the square root of my sample size, which is 17. So that's going to get me my what's called the lower bound, or my smaller part of the value. So to do this all at once in your calculator, you're going to plug in the following. 118.65 minus 2, parenthesis 144.34, division. You want your square root key. It's second. I believe it's the second button. And x squared. And then go ahead and close that out. Now remember, it gives you an extra opening here when you do square root, so you got to close those two out. So for your lower number, you should end up getting 49.63. So then you're going to go ahead and do that again. But in this case, so you're going to want to plug in almost the exact same thing. The only difference is you want, instead of a minus there, you want this to be a plus. So you're going to hit second entry. And now you should see this line again as if you're ready to hit your enter button to solve it again. So use your arrow keys up at the top and scroll over. And once you get to right here, just go ahead and hit that plus sign, and it should change the minus from a plus. That way you don't have to plug all that stuff back in again. So once you do that plus, you should end up getting 189.67. So then, again, we're doing a confidence interval. Stuff is distributive normally. So 95% of the time, I will see values, or I will see some sort of alcohol or tobacco anywhere between 49.63 seconds and 189.67 seconds in Disney movies from the years 36 to 97. Again, like I said, this is very heavily done with calculators, so you're going to need to pause when need be. And remember, if you're not practicing this, you're not going to know how to do it when it comes to test. Okay, next example. So the study, there's a study done for people who were able to walk normally to see how long they could walk in a straight line, like what their cadence was, so strides per second. And they did this for 20 randomly selected men. So we're going to go ahead and construct a 95% confidence interval to talk about the cadence, again, or that stride per second of these 20 guys. So first we're going to find the mean. So go ahead and pause. We're going to get 1851. We're going to divide that by that 20 because we have 20 guys in there. Then we need to find our standard deviation. Which we get as 0.08. So we need to find our upper and our lower bounds. So we have 0.93 minus 2 times 0.08 divided by the square root of 20, which gives me 0.89. And then same kind of idea, 0.93 plus 2 times 0.08 divided by square root of 20, which gives me 97. So the rough cadence, the 95% interval, confidence interval of these 20 men is roughly between 89 seconds, or excuse me, 0.89 steps per second and 0.97 steps per second. And our last one. So the following values are calories per half a cup of serving of 17 different types of chocolate chip ice cream brands. Excuse me, chocolate ice cream brands. Which, if anyone counts calories, those are kind of a lot. Especially that 290 over there. So what we're going to do is we're going to go ahead and construct the 95% confidence interval. So again, we're starting with that mean. So 2820 divided by 16, because there's actually 16 there. And standard deviation. Which is 45, which again, remember, having a standard deviation that high is talking about the average distance between each data point. So having such a high standard deviation is pretty crazy when you're thinking about all those calories you're ingesting. So to find our lower one, we do one Oh, I never answered that. Back up. Let's try that again. So 176.25. My apologies, guys. So then again, yes, standard deviation. It's 45. So then, oops. Trying to write that formula again for him, so I just wanted to use it. So then I take that 176.25 minus 2 times 45 divided by the square root of 16. Give me that 153.75. And then 176.25 plus 2 times 45 divided by 16, square root of 16, which gives me 198.75. So if most ice cream brands for half a cup intake, you're eating anywhere from 153.75 calories to 198.75 calories. Which is crazy, but who doesn't love ice cream? All right, that's all I got for you. So, have a good day.